we are going to get started. Thank you everyone so much for coming to first week of SQL and Python for data analytics. I hope you all are very excited to be here. I recognize a couple people from the Excel workshop earlier this semester, so welcome back. A couple of just kind of housekeeping heads up before we get into this for today. If you didn't check your name off on the computer outside, please do that at some point today. It just helps the digital lounge keep track of attendance. And second thing you should know is that this workshop is going to be very hands-on. This might feel a little bit more like a kind of hands-on lab session than a class. So you should be ready to have your hands on the keyboard, be writing a bunch of SQL today in our session. I will explain all that when we get there. I'm going to do a little bit of intro to start, but you're going to need to go to this link, which is going to have what you need to sign up for and use the tool that we're going to be using for both people. It's totally free and it's totally in your browser, so you don't have to download anything on your computer. It's all going to run in the browser. Okay, cool. First of all, it's nice to meet all of you. My name is Rachel. I've been teaching these workshops at the Digital Lounge for the last, I think, 3 semesters. Really enjoy getting a chance to work with all of you. I did not come to data from a super technical. I started getting a little bit interested in data and the computer school for computer science. I currently work at a podcasting tech startup that does podcast advertising. So we have a ton of data every time our podcasts are downloaded, every time you hear an ad in one of those podcasts, we have data on all that stuff. In this class are stuff that I use at my job every single day. So the idea is for this to be very practical for you, something you might be able to use at maybe some of the courses that you're working with, if you have data sets that you want to get a little bit deeper into, as well as internships or jobs that you all might be looking toward for the summer after graduation. I would like to get a sector. So if I could just get like a 1 to 5 finger stick. Do not fear. We are going to start here. Cool. So what are we going to do in our session today? We are going to use SQL to answer questions about a data set. If you don't know what SQL is, don't worry. We're going to cover that in a moment. We're also going to learn how to, and then once we get a foundation queries where we'll do things like join different data sets together, right? Go like raise your hand if you're stuck. I'll come over and help you. This is intended. My intention is for you to leave this class feeling your workshops. It's a tool that visualization, which we'll touch on towards the end of this series of 5 workshops. And I also picked this tool to any other sort of SQL tool you might see if you're working those types of spaces for that. You are not required to come to any of these sessions, but if you're interested, I encourage you to come to all of them. They are going to build on each other conceptually. So for the first 2 weeks, we're going to be covering tool that kind of works in concert with SQL, works together. We'll get into that more deeply in week 4. And then in week 5, we'll kind of put it all together and come out with a little bit of it's intended to be sort of like a small portfolio project that you could use to sort of showcase what you've learned in this workshop. So that's what you can expect, that those sessions will all be here at the same time. I don't think we're skipping any weeks. I think it should be just the next 5 weeks. Okay, so that's all that. We're going to get into SQL. So what is SQL, or you might hear it called SQL? Both are fine. It stands for Structured Query Language. It's essentially a very simple programming language. So if you've ever taken any kind of intro to coding class, you've mucked around with some HTML, anything like that, that is another example of a programming language. SQL is a very simple programming language, and it's specifically designed to interact with databases. Now, you might be thinking to yourself that you don't interact with a lot of databases. A database, as I'm referring to it here, is just a structured collection of related information. So the simplest way you can think of a database is a spreadsheet. So if you were here in the Excel workshops, you might think back to some of the spreadsheets we looked at as examples there. I'm sure you've interacted with spreadsheets or CSV files of data, maybe in some of your classes, or maybe even just on your own, organizing some stuff for a club you work with or something like that. Databases are used by every single type of business or organization that you can think of. I mean, everything, apps, websites, social media, traditional media, retailers, like everybody is going to have data stored in some form of database. And the vast majority of those databases are going to be structured data that you can access and interact with via SQL. So it's very flexible. It's a very powerful tool. And it's great. It's a great one to learn, especially if you don't have a deep background in other programming, because it's got a pretty limited scope. It's specifically for interacting with databases. So there's not a ton of different stuff to memorize. There's sort of one structure that you can sort of learn variations on. So that's what we'll walk through today. All right. So who uses SQL? As I've mentioned, I've used it at a variety of different roles and projects that I've worked on personally. So obviously technical roles like a data analyst or a data scientist are going to use it. There's a lot of marketing roles that are interacting with large volumes of data. That's where SQL comes in hand. There's also a lot of non-technical roles, especially at more tech-oriented companies, where even a little bit of SQL knowledge is sort of either expected or kind of a bonus to have. So it's quite common if you work at a startup or a larger tech company to have access to company databases that are primarily sort of interacted with via SQL. Lots of other types of roles that interact with databases. I know many of you are here from communications or journalism programs. So if you think about media planning and advertising, those types of roles are interacting with a lot of data. Any variety of marketing or marketing operations type of roles. Any sort of customer or client facing types of roles tend to be interacting with a lot of data. And then of course, there's the sort of investigative journalism side of things where you might be able to get a lot of open source data or bigger files that you might be interacting with. So really a ton of use cases here. I would say the main places that you won't see a lot of SQL in use are in sort of these less technical roles at more legacy companies. So places that might have sort of older software in place or sort of running on that infrastructure might have a little bit less of this, but pretty much everywhere else, you should expect some likelihood that you'll run into this in the working world, right? Okay. So we've talked a little bit about what SQL is. Let's talk a little bit more specifically about what it can be used for. So this is going to sound pretty simple, but it's actually quite powerful when all these things are combined, okay? So the data sets that we're going to be working with today are two data sets related to an old TV show called Seinfeld. Some of you may have seen, some of you may be too young for that, I don't know. But we have two data sets that we're going to be working with. One is data about every single episode of that show and how it was rated at the time. And then we've also got a data set that's every single line of dialogue from that show. All right, so those are the two data sets that we're going to be working with today. So to start to think about if that's the data that we're working with and if SQL is the tool that we have in our toolbox, what can we do with that? The main thing that SQL is used for at its most basic is to find data that meets certain criteria, okay? So you can think of this as anytime you're filtering a website, you're shopping for clothes online and you filter for your size, that's a very simple form of selecting some data, some of the merchandise at the store that fits the criteria. In this case, size large or whatever you've selected. So when we think about our data set that we're going to be working with today, we have all kinds of information available to us. We have the episode titles, the numerical information about the rating. We have the dates things were aired. We have all the text data about which lines were said by which characters and which episodes, right? So we've got a lot to work with. So a very simple example of a question that we could ask is, what episodes have a certain word in the title? That's a query that we could run. It's very similar to maybe searching Netflix or Hulu for a show that has a certain word in the title, right? We can also summarize data with SQL. So this starts to get to more roll-up kind of information. Things like how many episodes are in each season of this show? What's the average rating for this show across all the episodes? That type of summary information. We can manipulate data, so we can change or augment our data. For example, we can say that if the rating of a particular episode is above 8, we're going to consider that a good episode. And if it's below that, we're going to consider that a bad episode. All right, we can use SQL to sort of add a new column to our spreadsheet that says an episode is good or bad instead of a numerical rating. right? That's a very simple example of a data manipulation that we could do. We can also group our data. This is quite powerful. So if we want to say, we don't want to know the average rating just across all the episodes, but we want to know for each season, what's the average rating of episodes in that season, compare across seasons, that's the type of grouping that we can do. We can order our data, so pretty straightforward. We could sort by any sort of sortable characteristic, alphabetical, by date, numerically, etc. And we can also combine data. We're just going to very much scratch the surface of this today. We'll get into this more next week. But as you might know, if you've undertaken any sort of data project in any of your classes, doing any of these steps that I just mentioned with multiple data sets, combining multiple data sets together, can be where you start to get some of the really interesting analyses. That's where you can kind of get a little bit more than sort of meets the eye with some of your data sets. So each of these alone, pretty straightforward. When we combine them together, pretty powerful. So that's what we're going to be doing with some of our queries. Okay, so I'm going to stop talking about SQL for a second and talk a little bit about Hex, which is the tool that we're going to be using. You can think of Hex as your kind of personal notebook or worksheet for this workshop. Hex is going to allow you to write SQL or Python. If you don't already know Python, I would encourage you to just sort of skip the Python button until week 3 when we talk about it. But it's essentially going to work as a series of cells that link together. What does that mean? If you come to all 5 weeks of this workshop, what that might mean is in our last week, we're going to put together sort of an overall analysis, or maybe a small app is a way to think of it, like a data app. We can write a little bit of Python that can do something like load our data into our database. We can write a little bit of SQL in our next cell or our next sort of unit that might join our data together or do some of the manipulation that we just talked about. We might write a little more Python if we want to do something a little fancier with a function. And then we might put in another cell that's going to build a cool chart, visualize all the work that we've just done. All right. So Hex works in this series of cells. You'll see that today today we're just going to write a bunch of SQL cells, but they're going to sort of build on one another. You can refer back to the results of previous cells that you've created. All right, this will make a little bit more sense once we look at it, but that's the concept to just think of. It's sort of a series of cells that link together. Okay. All right, so hopefully some of you have done this already, but we're going to make sure you get set up with Hex. So you should go to this link, put in your email. That'll give you the sort of proper, it's like a long, funky looking link to log into Hex. That should bring you to a page like this. Make sure you log in with your USC email here, or you can do your USC Google or Microsoft. Once you're in there, you should see a couple of projects listed. All right, looks like I left my screenshot for spring, but you should see a project with this title, Fall 2025, Week 1, Intro to SQL. All right, so you should be looking for that project and you should make a copy of it. All right, so when you see it in the list, what you should do, or if you already have it open here, like this, if you've already clicked on it, you can come to the top and you can just duplicate right here. You should make a copy. I would name my copy something like Rachel, Fall 2025. Week 1. And then this is your personal copy, your personal kind of notebook or worksheet that you can use for today's session. All right, I'm gonna give everybody a second to sort of click through that and make their own copy. If you're having issues with the link, you can't find it, give me a little wave or a little shout and I can help you out. Yeah.
You can see the turn around myself.
Okay, so you want to go to should be on your home screen. Check collections.
Oh,
Yeah,
and
fall.
choose this.
Yeah,
All
okay,
right,
if you don't
thank
see it
you
on the
so
home
much.
page, it should show up on the home page, but if it does not, you should click collections. So your home page will look like this. I've got a bunch of junk in here, but you would want to go to collections if you don't see anything, and then you should see a fall 2025. And then with fall 2025, you can just hover, do your 3 dots, and then you should have an option to duplicate. All right, second. Yeah.
So I must use my USC to join the Hex.
Yep.
点不一样，真的。Rachel, could you like show again the link?
Yeah, no problem. You want me to show them that? Okay. Yeah, so all you should do is you should be from here. You should click on this link. As
Before this link.
so this guy. Yeah. All right. So yeah, if you came in a little late, go to the link on the whiteboard. All right, that'll get you to the longer link, which was ickier to copy paste. Okay. When you're in here, again, under collections, if it doesn't, it should pop up on your homepage, but if it does not, go to collections, fall 2025. You're looking for week 1, and then you're gonna do ... and duplicate. I get a little like thumbs up if you got your copy working. See where we're at. A few people, okay. I'm gonna give everybody a minute because if we don't do this step, we can't do anything else in the class today. So I'm gonna give you all 1 more minute to get that sorted out, and then we will keep moving. Anybody not have a copy? Anybody have issues? Doing okay? Okay. Excellent. All right, so once you have a copy of our fall 2025 week 1 project, again, if you don't have a copy yet, you can do the ... and hit duplicate, or if you've clicked on it already, you might have it open like this. That's also fine. If you have it done this way, just make sure you come to the top, do the little arrow and do duplicate right here so you have your own copy. Okay, I will do this real quick myself. I'm gonna make a duplicate. I have one to demo with. All right, and I'm gonna call this something like Rachel's copy. All right, so I can just click on the top here and make my own. Okay, everyone should have something on their screen like this, your own copy, and it should start with this sort of silly GIF from the TV show. Does anyone not have this on their screen?
So what should we do to make that all copy?
Make your own copy? Yep, you should the down arrow right next to the title there and just hit duplicate. Yep. Anybody else not have this quite yet? You good over here? Okay. All right. Fantastic. So I'm going to give you a little bit of an orientation to what you're looking at here in Hex. As you scroll down, you will see that there's already a series of cells in here that I've sort of pre-populated for you. I've sort of given us a little template or a little worksheet for class today, okay? There's a few different types of cells that exist in Hex, and you can add a cell anywhere in your own copy. To add a cell, you'll see as you sort of hover in between, like above or below any cell, any of these kind of squares, you'll see this plus sign in the middle. All right, so you can kind of hover anywhere and see this little plus sign to say add cell. When you do that, I'm going to click on add cell. You can see all the different types of cells that we can add to our project. All right, now mostly today, we're going to be adding our SQL type cells. All right, that's what we're mostly going to be doing. A lot of the cells I've already put in here are markdown, which is just sort of a formatted text. All right, so that's how I've sort of embedded this little image right here. And that's how I've sort of written out some of our little instructions that are in here, okay? So what we're gonna be doing today is going through and adding SQL cells as we go. You can add as many as you want. You can delete them. You can do a few as a test. You could do whatever you want. All right, this is your copy, so you can add as many as you like, right? There is one little piece of code that I have sort of pre-populated in your workbook for you, and that is this little chunk of code right here that starts with import pandas. This is a chunk of Python code that we're not going to talk about today. I will explain what this code is doing in week 3. If you're dying of curiosity, you can come ask me after class. We're not going to talk about what this code is doing today, but it's just loading our data, getting it ready for us to use in SQL. So once you have your copy open, you should scroll down until you see your little import pandas button. And then you're gonna come over here and run the cell by clicking this little triangle kind of play button in the upper corner. This is gonna be your run button. All right, where we are running the cell. What does that mean? We are executing the chunk of code that's inside this cell, which in this case is loading our data. You will know if that worked if these little kind of terms underneath it turn green. All right, so you should have a little green text underneath that says transcripts data and ratings data once you run your cell. Okay. Anybody not able to run their cell? Doing okay so far. Okay. A couple more things that you should know about just navigating around in Hex. The two data sets that I mentioned, right? We have our data on every line of dialogue in the show. That's our transcripts data. And then we have data on the rating of every episode. That's our ratings data. Those, you can think of those each as sort of our two spreadsheets. Okay. You can see what is in those data sets in our data browser, which is going to be the top sort of icon on your left-hand toolbar. This one with a little lightning bolt on it. It says data browser. If you click on that, you're going to go into your data frames option here. And then you're going to see this little list with just two things in our data frames. This is our ratings data and our transcripts data. This is a handy little view for a couple reasons. It's going to tell you how many rows of data we have. So you can see our ratings data has 172 rows and our transcripts data has 54,000 rows. All right, that makes sense. We're expecting that data set to have a lot more rows because there's more lines of dialogue than there are episodes. Okay. When I click on each of my data sets, I also get a little bit more information about what columns are in those data sets. All right, so I can see that there's 6 columns in my ratings data set. I can see what they are down here. And same thing with my transcripts data. This is going to be really important when we're writing some of our queries. So you can open and close this as you want today. Just click this little icon. You can pop it open and closed. Okay. Excellent. So we're almost getting ready to write our very first query. But let's first talk about how we write a query. What does a query look like? So in SQL, a query is always going to start with the word select, and there's going to be a bunch of other things that it may or may not have. The queries that we're going to be writing today are always going to have a select something. In this case, that'll be the columns of our data set that we want, or the columns of information that we want. And then from is going to tell us where we want that data from. So we have 2 places we can select data from right now, our transcripts data and our ratings data. All right. So we could select all of those columns, any of those columns, specific columns. We could start to do some manipulation of those columns. All of those things are examples of queries that we're going to write. And then there's a bunch of other things that we can do here in our query that are going to sort of correspond to this list of things that we talked about earlier, right? We talked about being able to group data or order data. And you'll see here that we can group by certain columns or order by certain columns, right? So SQL is pretty straightforward. It's going to feel a little bit more English languagey than maybe some other programming languages that you might have dabbled in. It's basically just going to sound like weird robot English, but it's almost like writing out like a weird sentence, if that makes sense. Okay. Last thing I'll say about this, you'll pretty commonly see these words written in all caps. So select from, etc. That's a convention. It's not required. It works fine if you don't. I often don't, but that's totally up to you. Okay. So we are going to write our very first SQL query. So what we're going to do is hop into our text, your own copy. You're going to scroll a little bit down. I made a little, all the text I just talked through on that last slide is here for reference. All right, and we're going to go to our first task. Our first task is going to be writing a couple of simple queries. Okay. First thing we want to do is just look at the first few rows of each data set. This is something you want to do anytime you're working with a new data set. You want to put your eyeballs on the actual raw data, make sure you understand what it looks like, make sure it looks like how you expect it would look. All right. So how do we get the first 10 rows of a data set? In this case, I added a little blank SQL cell for you here, so you can just put your cursor in here and type along with me. You can also add more SQL cells. Again, if you hit this little plus and hit the SQL button right here, you can add more. Okay, so I'm going to start with our very first thing. I'm going to type the word select to start. You're going to be typing that word a lot today. That's the start of every query. Then I'm going to type star or asterisk. All right, that is just going to mean everything. Select everything. From is my next word. That's going to tell me which data set I'm selecting from. I'm going to pop my little data browser open for a second. And again, under data frames, I should see that I have two different data frames, right? So I want to type in one of these names exactly. Let's start with our ratings data. Also, you'll see as I start typing, Hex is pretty smart. It's sort of doing an autocomplete suggestion for me. I'm just going to hit tab to get that autocomplete. All right, now I'm almost done. I've got select star, select everything from my ratings data. Pretty good, but I don't want to load all the rows of data. I just want to load the first few just so I can look at them. So I'm going to add one more thing, which is the word limit. Okay, I'm going to add the word limit, which is going to allow me to limit what I'm selecting to a certain number of rows. I can do any number I like. In this case, I'm going to do 10. So select star from ratings data. Make sure you get the underscore in ratings data so it's spelled the same way. Limit 10. Then I'm going to run my cell. All right, so I'm going to hit the same sort of play icon in the side. You can also do Command Enter on your keyboard, and that will do the same thing. Yeah.
So it's inclusive in this case, like 10?
Yes. Mm-hmm.
Yeah.
Yes. Good question. So yeah, this will return just like the natural number 10 of things. You'll notice that the little row numbering here is going to start at 0, but it's going to go 0 to 9. That'll give us 10. Okay, so once you've run this, you should see pop up right below it this little table. If you don't see this table, make sure that you hit your little play button right here, and that will give you your results. Okay, so let's take a look at what we got. So we got a season number, we got a title. These look like TV episode titles. That makes sense. Air date, looks like we've got something in a date format, makes sense. We have our rating for each episode. We have the number of votes that rating was based upon for that episode. I don't know exactly how TV rating worked in the early 90s, but based on some amount of votes, it appears. And then we actually have the full text description of this episode, which is pretty fun, right? Jerry's apartment is robbed. Jerry tries out excuses, right? All right, and I can see in my data browser on this side, when I click on ratings data, these are my 6 columns. And then when I look across here, I can see my 6 columns appear across here as well. All right, does anyone not have this table pop up? Any questions? All right. Yeah, question. Yes, the star is just all the columns. All right, so it's just a quick little shortcut for all the columns. We can specify which columns we want in a query. So let's say I just wanted the season number and the title. I could spell those out specifically. I could say season, comma, title. All right, and I could rerun my query, and you'll notice that my results are exactly the same in my first 2 columns, and just the rest of my columns aren't included because I didn't specifically mention them. All right, if you want all the columns, it's kind of a pain to type them all out, so it's a little shortcut to do your select star. Yeah. Yeah, Hex can connect to a lot of different types of data sources, internet databases. In this case, it's giving you sort of a demo connection to a different database software called Snowflake. Data frames just means it's already been loaded into our project. It's already accessible to us in sort of our local copy. Yeah, question.
Doing select, can we do like a range instead of just like if you don't want to do all of them, you don't want to type each one in?
All the column names?
Yeah.
Not in this variation of SQL. There might be a more advanced version out there somewhere, but not here, unfortunately. SQL is a little bit of an old-fashioned language in some ways. Okay, great. So hopefully you all got this. You got a little table spit out here. You've already written your first SQL query. Pretty exciting. We're only 33 minutes into class, so pretty good. Okay, next we're going to write the same query, but for our other table. All right, so I want to see the first 10 rows of my transcripts data table. Easiest way to do this is going to be to come right underneath and add a new cell. You can only run one query per cell. All right, so you're going to add a cell. Make sure you add the SQL type so it knows what to look for. And then you're going to type in a query here that's going to get you the first 10 rows of your transcript data. I'm going to give you all a second to write this before I write it, but I'll give you a hint, which is it should look exactly like this one, except for what you're selecting from should be different. Okay, so you should write a query here in a new cell that's going to select the first 10 rows of your transcripts data set. Right, give everyone a second to try that. If you write one and you think you got it working, you're going to hit run and make sure you get a little data table underneath. That's how you'll know it's working. All right. Anybody get some transcripts data rows showing up? Yeah, back here, what'd you type in? Select. Select star from transcripts data. Great, it's even gonna give me a little autocomplete, so we'll just go with that. Limit 10. Fantastic. I'm gonna hit run, or you could do command enter on your keyboard. Boom, I've got my data set. Excellent. Okay, let's take a quick look at this data set. In this case, our first column is kind of a weird unnamed column, but it looks like it's just the row number, so pretty straightforward. I've got the name of the character. It's Jerry or George, these first few lines. And then I have the actual line of dialogue, the actual text of what the dialogue is, including if it's really long, I can expand these out and see how long they are, right? Going a little further over, I have my episode number. I have something called an SEID, and then I have my season number. All right, now this is a great example of why it's good to always look at some just rows of your raw data before you start doing any more analysis, because it might not be super obvious what SEID is, but when you look at it here in the data set, SE01, SO1, E01, etc., you can start to tell that what this probably is a little code that means season 1, episode 1, right? So that would be a little hard to tell from just looking at our data browser right here, but pretty obvious from just looking at it with our eyeballs, right? So this is always a good step to do. Okay, written a couple SQL queries, looking pretty good. So we had 2 parts to our first task. First part, we already did, right? Get those first 10 rows of each data set. Next thing we're going to do is just check the number of rows in each data set. All right, this is always a good habit to make sure that number makes sense. Now, in this case, Hex is cheating a little bit, is sort of telling us the number of rows that we already have, but let's double check that with a query. All right, so we're going to add another cell. I'm going to scroll down below the cell that I just made. I'm going to hit add cell. I'm going to hit SQL. And we're going to do a new type of query where we're going to count the number of rows. So I'm going to start with select because we always start with select. I'm going to do count, the word count, parentheses, star, close my parentheses. All right, so this is saying count everything. And then from my ratings data. Okay. When I run this, I'm going to get a little small table with just one sort of piece of information as the result instead of my bigger table. It's going to say 172. All right, so my query here is select count star from ratings data. This is sort of a quick shortcut query to figure out how many rows you have in your data set. First thing I want to check is that it matches here. Of course it matches, so that's what Hex is doing. But second thing is that I want to make sure this number makes sense, right? If my ratings, if this query, for example, returned 17,000 instead of 170, there might be something wrong with my data set, right? I might have imported a bunch of blank rows or something. All right. And always a good idea to do that for any data set you're going to work with. So I'm going to write that same query for my transcripts data. So double check how many rows are in my transcripts data set. I'm going to do select count star, keeping that star wrapped in parentheses here since count is a little function. from my transcripts data. All right, and I will see that this number here, 54,616, matches what Hex is telling me as well. All right. I'm gonna do one more thing here, one more little trick. Anytime you're selecting a column in SQL, which is essentially what we're doing here, right? We're selecting what turns out to be, what results to be one column of information. You can give it any name you like. You can give it sort of an alias name to that column. If I don't do that, it's going to be sort of some sort of like weird default value, in this case, count star, which is a little odd. It might be nicer to name this something like number of rows, for example. So I can use the keyword as, which will turn blue. So you'll notice Hex is helping you out. If you're spelling the keywords correctly, they're going to turn blue. Select count star as, I could do something like number rows. All right, now any alias I give it is going to need to be, have no spaces in it. By convention, it's usually this little underscore type of thing. So I'm going to do number underscore rows. I'm going to run my query again, and then I'll see I've got the same little result table, but it just says number rows here, a little bit of a nicer label. All right, I think we have a couple folks just joining us. If you're just joining us, start at this link, and there's some instructions to get to the notebook for how to follow along. All right, any questions about how we're getting the number of rows? Anybody not get a number, or anybody get a different number? Okay. Excellent. All right, so that's 4 SQL queries already. Not too shabby. Okay. All right. Cool. A couple more pieces of information about Hex as we're sort of getting around, right? So Hex is built to do 2 things. It's built to both do your analysis, but also present your results. So it's got sort of 2 modes built into it. At the top, you'll see 2 little kind of rectangle-y icons. All right, this first one is going to be for our notebook, and the second one is going to be their app builder view. Okay, so when I switch to their app builder view, I'm going to see some things that look similar, right? I'm going to see the same silly GIF that's at the top of my notebook view. I'm going to see some of the same text. And when I scroll down to task 1, I'm going to see one of the sort of results tables that I got from my query, but I don't actually see the SQL itself, right? There's no select statement here. It's not visible in this view. This is something I really like about Hex for collaborating with other people. So I pretty frequently write a bunch of SQL queries to get some results, and I just want to share the results with someone else, maybe someone who doesn't know SQL, doesn't need to see the queries. So this is the same document, but it's allowing you to decide what you want to show in sort of this display view, which is pretty cool. If there's anything you want to include in your display view, you can come in to any of your cells, and on the right-hand side, there's a little icon that sort of looks like a quilt. You can remove or add from your app builder. So let's say I want to add my little transcripts data query here to my app builder. I can click that icon. I can pop over at the top, toggle over to my app view, and now I've got 2 data tables here instead of 1. All right, we're not going to use this a ton today. We'll use this as we sort of move a little bit later in this series of workshops to do sort of our visualization portfolio project type of thing. But you can start to see how it's helpful if you're writing a bunch of SQL, and then you can just pick your polished results, put them here. You're not copy pasting things between multiple documents, etc. Okay. All right. This. Okay. Excellent. One more thing that I will mention here about Hex is, I guess kind of relates to what I've already mentioned, but it'll make a little bit more sense now that we're in it. So I mentioned earlier that Hex is sort of a series of cells that can talk to each other, okay? And specifically, they sort of go in order. So what that means is anytime I write a query, it's actually going to generate the results of that query are going to generate another data frame. All right, so another table of data that I could potentially pull from. So if I look at this very first query that I wrote here, the select star from ratings data limit 10, I'll see right below in little green text, it says the word data frame, all lowercase. This is the sort of auto-generated name that it gave to this data set. And it's making it available in my data browser so that I could go query separately now from this data set if I wanted to. So these results, anytime you have results, those can become something else you can query. I can rename these, which is quite helpful if you're going to refer back to them. So I might name this something like first 10 episodes. Again, this name would need to have all no spaces in it. All right, so I might rename it something like this. I can go to my data browser. It's going to update with that new name. Also, once I've renamed it, I'm going to come in and actually write a query of this data frame. Okay. So I created this little data set from my query before, and now I'm going to run another query on it. So let's see how many rows are in this data set. Now, this is not a huge mystery because in our previous query, we set the number of rows it was going to have. So this query, if we count the number of rows in there, hopefully you might be able to intuit what number is going to come out. All right, so we're going to do select count star from, but instead of using ratings data or transcripts data, which are sort of our real data sources, if you will, we're going to refer to that first 10 episodes one that I just created right here. All right, so select count star, that star is wrapped in parentheses, from our first 10 episodes. And I'm going to run that or do command enter. And then I'm going to get my little result right here as 10. All right, just what I expected. One more cool thing happens here, which is that now next to our little data frame from before, first 10 episodes, this little number 1 popped up. This is telling us how many other times did Hex refer back to this data set? How many other queries are depending on this data set? Which is pretty cool and helpful, as you could imagine. As you start to have a long notebook, you're doing a bunch of analyses, you can see what's actually depending on the queries that you're writing. Okay. Any questions about getting around in Hex? I know there's a lot of buttons in there. Feeling okay so. Okay. Awesome. Okay. So we're going to get into our next task. Scroll down a little bit. All right. So we're going to start talking about how you start from a question and get to a SQL query. All right. So I think the easiest way to try to think about this is your query should come out to be sort of like a weird robot English version of something that sort of makes sense to answer this English language question. So when you have a question like this, there's a couple sort of things you're going to do to figure out how to write your SQL query. First thing you're going to do is figure out which data table you should select from. All right. So these little ones I just made are not super helpful. We're going to focus on the 2 that we started with, our ratings data and our transcripts data. And we're going to look at the columns of those. So if I want to find out which characters in Seinfeld speak the most often, I'm going to want to look for a data set that has character as a column. Right? That's a field I'm going to need in order to answer this question. If I look at these 2 data sets, ratings data does not have character as a column. Makes sense. But our transcripts data does. All right, it has character, and conceptually, this data set is 1 row for each line of dialogue. So I can sort of use the context clues here to understand that I'm going to need to select from my transcripts data for this query. So usually what I do when I'm writing a query is I start by writing something very simple. All right, so I'm going to start with maybe something like select star from the table that I've identified has the data that I need. In this case, it's my transcripts data. Okay. Next thing I'm going to do is start to think about, okay, what columns specifically do I need? So I don't actually need all my columns for this query. This query that I've written right here would work, would run, would give me results, but they're not quite answering this question. So next thing I want to think about is what column or columns do I need to answer this question? Pretty straightforward. If I want to know which characters speak, I'm going to need to select the character. Yeah. So I'm going to get rid of my star. I'm going to come in and edit my query. This is usually how I write them, right? Start with something simple, sort of go back and edit it a couple of times until it gets to what I want. So I'm gonna say character, and I'm gonna need something else here, but I don't quite know what that is yet. And I want to see if my sort of query in progress is working. Does it run as it is? Okay. So something else I often do as I'm writing my query is to just try to run it. If I have part of what I think it's going to be, I'll try to run it, see if it works. Okay. So I'm going to write, this is a pretty simple query, select character from transcripts data and see what my results are. Now, this is starting to look pretty solid. All right, so I have my character column and it looks like I have about 55,000 rows. That makes sense because I'm not filtering out any rows. So it's going to have the same number of rows as my original data set. And it's going to give me all these character names. All right. But it's listing each character multiple times. Okay. So I want to be able to count these rows, but by character. So I'm going to combine with this query with the query that we just wrote before, where I was counting rows with count star. I'm going to do select character, comma. If I'm selecting multiple things, I need commas in between. And I'm going to say comma count star from transcripts data. Okay. I'll try to run that, and that is going to give me an error message. Okay. Error messages like this look really scary when you haven't seen very many of them and you haven't written very many SQL queries. Luckily for us, SQL is often pretty straightforward about what the error is. Okay, so you should generally skip this first sort of exception finder part. We don't need to know what that is. And then it's going to say column character must appear in the group by clause. Okay, what's a group by clause? Let's go back up to our little reference that I mentioned earlier. All right, so most queries are going to be select something from some table. Okay, but they might also have some of these other keywords. So in this case, our little error message was telling us that we're missing this group by. All right, we need to group by the character, and that makes sense, right? If it says Jerry, 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 George, Jerry, I need to group all the Jerrys together and see that there's 5 of those and 1 of George, right? That's conceptually what I'm doing. So let's come back down here to my query in progress. I'm going to add a group by. By the way, you can write your queries all in one line, or you can separate them out. You'll see both. As your queries get longer, it's going to be easier to separate them out onto multiple lines. So I'll start doing that here. And I'm going to say group by character. Okay. So tell me the character, tell me how many rows appear for that character from this data set, and group them by that character so that there's only 1 row for Jerry instead of thousands of rows. All right, let's give that a try. I'm going to run that again. Okay, now we're getting somewhere. So now this query is giving me 2,000 rows back. So it got smaller, right? I condensed it down as I'm summarizing. And it's telling me that audience had 3 lines and some guy named Artie had 4 lines. And it's got a bunch of other waitress, dry cleaner, salesman, right? It's got a bunch of these kind of, and you know, there's no small parts, only small actors or something, right? Maybe it's the other way, right? But I want to know about Jerry and George, right? I want to know which characters speak the most, not necessarily which ones are just showing up in the order that they appeared. So I'm going to add one more component to my query. If we go back up to sort of my menu of query options, one of them we haven't used yet is order by. All right, I can tell my results to be sorted by any of those columns that I just created in either direction. All right, so let's do this. I'm going to say that I would like to order by my second column here. Now, what is my second column called? It's not really called anything because I didn't really give it a name. It's just got this weird count star name. So this would be a good moment for me to label this column something. I'm going to bring in my as next to my count star. All right, and I might call it something like number lines. You can call it anything you want here as long as it's no spaces. So I'm going to do my little underscore. Okay, so I'm going to give this little alias because I want to refer to it down here, order by number of lines, right? I don't want them ordered alphabetically by character. I want them ordered by how many lines they have. Okay, so this is what I've got so far. I'm going to run that and see what I get. Okay. looks like this is very close to what I want, but not quite. This is giving me all the people that have one line, and I want all the people that have the most lines, right? So I need to flip my result. This is sorting them in order, but it's order from least to most. I want it the other way. So I'm gonna add one more keyword to my order by, which is that I want it in descending, not ascending order. The SQL term for that is descending, DESC. The abbreviation DESC for descending. Order by number of lines descending is what I've changed there. And then let's run that. Okay, this is pretty cool. So Jerry has the most lines, followed by George, followed by Elaine, followed by Kramer. Those are names that might be familiar if you've ever seen or heard about this show. So that kind of passes the gut check, right? That makes sense for the data set that we have. All right. Okay, so if we go back to our question for one moment, what characters in Seinfeld speak the most often? And we look at the query that we wrote to answer that question. Select character, count as number lines from transcripts data, group by character, order by number lines descending. It's pretty clunky, but it is sort of like robot answer to this question, right? So I would encourage you to think of these queries that we're writing as sort of a weird sentence. Though it's quite weird and clunky, it should sort of make sense to you that it's answering the question, right? If it does not, that's maybe a sign that you've got something to debug. Okay. All right. So we are going to write another query. We're just writing kind of a series of queries from here on out, okay? And we're going to sort of be adding components as we go. So our next task, our next sort of scavenger hunt item, if you will, I'll hide this so it's not showing up twice, is to write a query to find out which season has our highest average episode rating. All right, so we know from our ratings data that we have for each episode which season it's in and what rating it has. But we want to know which season has that highest episode rating. All right, so this one we're going to work on together a little bit. And we're going to do in that same structure that I just wrote our previous one in, meaning I'm going to start with sort of a simple query and then add some stuff. So let's start very simply. What am I selecting from if I want to find out my highest average episode rating? What should my from be looking at? Ratings data, excellent. Okay, cool. So I'm going to be selecting something from my ratings data. Fantastic. Now, what columns am I going to need from my ratings data to answer this question? My options. Do I need season? Yes, I need season. Do I need title? No title. Air date? No air date. Rating? Yes. Vote count? Probably not. Description? Definitely not for this. Okay. Excellent. So I've got season and I've got rating. Remember, if I'm doing multiple columns, I'm going to need that comma in between. Let's run that and see how that looks. Okay, great. That works. Looks like data that I'm interested in. Okay, now I'm going to need to do two more things. And they're very similar to the things that I did in this previous query. So we're going to come back to this. In this case, I was counting up a number by character. In this case, we're averaging a number by season. All right, so it's going to look very similar. I'm going to do, instead of doing a count on my second thing that I'm counting, I'm going to do an average on that second thing that I'm counting. All right. So I give you a little hint here. We're going to need to use average column. AVG is our SQL abbreviation for average instead of count. So all I'm going to do here is wrap my rating in this average with parentheses instead of my count with parentheses. All right, very similar. And again, I'm going to give this a little alias name, something nice like average rating. All right, and if I run this, I am going to get an error message. Same error message that I got before, which is going to tell me that the column season must appear in the group by clause. All right, anytime I'm doing any sort of aggregating function, I need to tell SQL what to group by. Okay, Seems like it should be straightforward because there's only one other column here, but I have to tell it explicitly. Okay. So after my from, I'm going to add a group by. All right, group by will turn blue, so that's a good sign. Group by season. We'll run that and see what that looks like. All right, great. This is looking pretty good. It's got season 5 was rated at 8.4, season 9 rated at 8.3. But it looks like these are in really no particular order. They're not in order by season, and they're also not in order by average rating. All right, so that means I might want to tell it what order I would like it to be in. In this case, I would like it ordered by my average rating. All right, so let's try that. Order by average rating. Give that a run. I can tell it's running if it sort of twirls at the top there for a moment. Okay, great. And now it's going to put season 1 at the top, which looks like it was by far the lowest rated. All right. And same thing, if I want highest rated at the top, I'm just going to add one more keyword for descending, DESC, and that'll sort it in order of largest to smallest. All right, it's going to think for a second, and it's going to tell me that season 8 is my most highly rated season according to that average episode rating. Okay. Trying to get a little fancier with the queries here, adding a few more components. We've got our total function, we've got our alias, we've got our group by, we've got our order by, right? So we're adding a few more pieces in. Any questions about this query? Anyone get an error message, different results? Feeling okay? All right. We're going to answer another question. What are all the names of the episodes in our highest rated season? All right. So we're going to add, yeah, question. Okay, great. You want to read it out to us?
Find your error, following written must be
Okay, so it's telling you to group by your rating column, which is a little funky. So 2 questions for you. What is in your group by?
It has season where
It's added quotes for you. Yeah, so the only reason it's adding quotes is in our data source, the columns have capital letters, so the quotes are telling it to look for that exact capitalization, but either one works. That should be okay. And then do you have your rating wrapped in sort of your average function up here, your AVG, parentheses on one side, parentheses on the other? All right. So you're selecting 3 things here. You're selecting season, rating, and then yes, exactly. Yep. That has to be grouped by our rating again. Okay, excellent. Okay, fabulous. So we are going to move to what are all the names of the episodes in our highest rated season. All right, so this is the component of SQL queries that's quite common that we have not used yet, which is a where clause. All right, so first thing you should do is write a query that's going to give you all the titles of all the episodes. Okay, so very first thing you should do, add a SQL cell. I'm going to let everyone take a stab at this. Okay. So don't worry about the where clause yet. First thing I want you to do is just write a query that's going to give us all the titles of all the episodes. Okay, should be a pretty simple query. Select one column from one of our data sources. Get that to run. All right, so I'll give you all a minute to try that. All right, does anyone have all our episode titles in a query? Just a little show of hands if you got episode titles showing up. Okay, a couple of you want to tell us what you got for episode titles? Up here in the second row?
It's like good news, bad news, the stakeout, the robbery. Like I got.
Yeah, that's right. Can you tell us what you what you
I
typed in?
see.
Yeah.
Yeah,
no problem.
select title from rating data.
Select title from ratings data. Very good. All right, great. Good news, bad news, stakeout.
Yeah.
Etc. Excellent. Okay. So this is the foundation of our query. Now we're going to add a component to our query that we haven't used yet called the where, which is like our filter clause. All right. So if we go back up to our little menu of options, I'm just going to scroll up here. Where is where we're going to add our conditions, our filters. All right. So we can filter our data on all sorts of things. We can filter it on whether text matches other text. We can filter it on whether it's greater than or less than a number, whether it's equal to a certain number, any of those types of things that you might filter in any sort of Boolean search. Same type of thing that we can do here. So I'm going to do select title from ratings data, where as my next keyword. And the way that I'm going to type out a where clause is I'm going to give the column and then a comparison. All right, so in this case, I want the season to be season 8 because we figured out up here that that's our highest rated season. So I'm going to give it the column name season, and then I want it to be where season equals 8. All right, so equal sign 8. Select title from ratings data where season equals 8. And first thing I'm going to notice is it went down to 22 rows up here. That's a good sign. That means I'm filtering down from my 172. And this very first one in the order changed. So that's a good sign. It's filtering out the one I know is from season 1 because I looked at the data earlier with my eyeballs. All right. They might not be in exactly this order, but you'll see your season 8 titles. Yeah.
How to look up like directly, for example, if we don't know it's season 8.
Yes, great question. So SQL gets quite powerful when you start combining your queries. So we definitely could do what is called a subquery, where we essentially paste this query. We need to do a modified query to sort of filter it out, filter out our not top options. But yes, we could sort of paste that into here instead of sort of hard coding our 8 and get that result that way. We're going to get into that a little bit next week. But yeah, that's exactly the right way to think about it. So as we keep building on our queries, they start to get really powerful when we combine them. It's also what's really helpful about Hex as a learning tool, right? Because you could do this query, see the result, do this query, see the result, and then you can write another query that combines them. You can sort of check yourself at each step and make sure it's working as you go. The short answer to what you're asking is we would add to this query a limit. So instead of limiting by 10 like we did before, we would just limit by 1 to get our very top. And then we would just select our season column to compare against. Yeah, good question. Okay, any other questions about what we did here with our where clause? Any error messages with your where clause? Everybody have something like this. I could try this with any other season number, right? I could try season 7. Any season number that's in my data set should work. If I try a season number that's not in there, let's say season 100, it's just going to turn blank, no data. Okay. All right. Cool. Let me just see if I here. All right, we talked about this. Okay. Fabulous. Okay. So we've covered a lot of sort of our standard query parts so far. So I'm gonna go back to our list and just do a quick little run through. All right, so most of our queries are gonna have select and from. They may have any of these other pieces. So they may have a where or not. They may have a group by or not. They may have an order by or not, and they may have a limit or not, right? We've seen a bunch of examples of these as we go. And in my select, we might have just a particular column or a few columns. We might have a function of those columns. You're kind of starting to see already, we have a bunch of different options. We can combine them in a bunch of different ways, but we're starting from a fairly limited set. So any query that you're writing should look something like this. If you're getting an error message, the very first thing to check would be, do you have a select? Do you have a from? Are you grabbing the correct labels of things for each of those? And then when you look at this list, do you need any of these? And if you need them, do you have them? The other thing I should mention is that these are always gonna, if you have them, they're gonna appear in this order. What I mean is, if you have a group by and a where in your query, the where has to come before the group by. Similarly, the select always has to come before the from. All right, so this is sort of your waterfall. You don't have to do every step, but you do have to go in this order. All right, that's why I left this as a little reference. It's in your little doc, so you can come back and reference it anytime that you like. All right. Cool. Okay, so we are going to get practice with all of these components a little bit more. Specifically, the one of these that we haven't used yet is join. So the next thing that we're going to do is write a few queries that are going to sort of lead up to us being able to join these two data sets together. All right. So to do that, we are going to incorporate a couple of other components that are going to let us aggregate a little further. All right. This guy. All right. So before we get into our functions, these are the functions that we're going to work on for the rest of our session. Let's go back to talking about our two data sets for a moment. If our ultimate goal is to join our two data sets together, what do we need in order to do that? We need some piece of information that'll tell us which row or rows in this data set goes to a row or rows in other data sets, right? So if we go look at our little previews again real quick, I'm just going to scroll up to our little 10 rows of each. My ratings data has my season, my air date, my rating, my vote count, etc., and an episode title. And then my transcripts data has character, dialogue, episode, SEID, and season. So if I'm thinking about joining data, the very simplest sort of way to think about it is I'm looking for columns that are going to overlap between my two data sets. So what's sort of a unique identifier? For example, let's say we had the email address of everybody in this room in one of our data sets, and then we had another data set that was everybody enrolled in some other class, all their email addresses. If we were going to join those together, we could figure out sort of which email addresses match between the two, meaning let's say for the class, this other class, we only had student ID numbers, and here we had student emails. There's no direct way to match those, right? Unless you went and asked each individual student what their student ID number was in this class, and then we could compare, see if anybody's double enrolled, right? So you're going to need some piece of information that's common between the two so you can compare. So when I look at this data set here, and when I look at my ratings data set, I want to look at what columns I have in common. First thing I'm noticing here is that season, my first column in my ratings data, is in my transcripts data. So my seasons are matching, which is very good. Okay, now seasons aren't quite sort of granular enough to match between these two data sets because this is actually a row for every episode. So ideally, I'd want to be able to match which specific episode to some information about what's in the transcript. Okay. Here's where it gets a little tricky because my transcripts data set has an episode number. And in fact, it has this nice little nifty ID number that combines season ID, episode ID, right? But in my ratings data, I have no episode number. Episode number is kind of missing. Now I can tell, again, another reason we sort of look at the data, I can tell by the air date that these episodes are listed in order, right? January 23rd, January 30th, February 6th, right? These episodes are listed in order. So it's not that hard for me to say, okay, this episode is episode 1, episode 2, episode 3, etc. By the time I get to here, this would be season 2, episode 1, season 2, episode 2, etc. Right? That's pretty easy to see. But I don't want to go through and type that in to 172 rows, right? So if I want to combine my two data sets on an episode level, I'm missing a column here that tells me my episode number. I would need that column in order to combine those two things, same way I would need student ID number to combine two data sets from two different classes. So the next couple queries we're going to do, we're going to add a column to this data set with our episode number. We're going to generate an episode number column to add here using a couple of functions that is going to allow us to join our two data sets. So let's come back down here to, we are on our task number 5 for today. First function that we're going to look at is our row number function. All right. So we are going to add a column to our rankings data set that just prints out the row number. Now Hex is already doing that for us. So if I come back to my ratings data, sorry for the scrolling. If I come back to my ratings data here, this little Hex interface is giving me a 0 through 9, right? As we mentioned earlier, it's giving me my little numbers here. But those aren't in any way I can access. Those aren't stored in a column that I can query from. So I'm essentially going to do the same thing using my row number function. So what does that mean? When I'm augmenting data, I'm going to select all my columns and then add more. All right. So selecting all my columns, we've already done a few times. The way I would write a query with all my columns is select star. All right. So I'm going to do my select star from my ratings data. All right. This is a query we've written a couple of times already. But this time after my star, I'm going to add a comma. All right, so I'm going to select everything and then this new column that I'm creating. Now this column could be anything, right? I could put in just a number, for example. Let's do this. So if I select everything, comma 1 from ratings data, it'll give me all my columns plus a column that just fills in the number 1 all the way down. Simplest example, in case you ever need just sort of a repeating like ID or piece of information, you can literally just type it in after a comma and it'll add it on to every row. Okay. Now we don't want to do that. This number is not meaningful to us. We want it to be a counting number. So we need a little function for that in SQL. Our function for that is this one I listed right here. It's row number. All right, so row number is a pretty simple little function. It's row underscore number, and then our open close parentheses. Nothing goes inside the parentheses here. We don't need to tell it anything. We don't need to like give it any further information. It'll just generate some row numbers. Okay. So instead of this just being 1s all the way down, it should hopefully be a incrementing number. Let's give that a try. All right, we are getting a little cranky with our row number function. All right. So next thing we are going to do is think about where we want our row numbers. Okay, so our issue here is that we've not told our function what to number over, meaning what we want to provide is a season number or an episode number within that season. Meaning when we switched from season 1 to season 2, we want our episode number to start over again at 1. Okay. Now, we got to tell SQL how to do that, which is where we're going to bring in our second function here, which is our partition. Okay, so partition just means sort of separate or divide. In this case, we want to tell it, hey, of all the rows in here, we want you to generate that number, but we want to do it within each season. Okay, so we're going to add on to our function right here because we're missing what it should number over. All right, in this case, we're going to do our row number over our partition by season. Our partition is going to be wrapped in parentheses. You'll see if you start typing it, you should get a little sort of auto complete partition by, and this is where we need to give it our column name. In this case, our column name is just season, if I can spell. And then the last thing I want to do here is, just while I'm here, I'm going to give it a little alias name, as something like episode number. Let's just this. Okay. Cool. So I've got my row number and my two parentheses, and then I've got to tell it what to number over. In this case, I want it to partition by season. And then I've just given it a little alias name with my ads. Okay, so I'm going to look at my results table here, and any column I've added is going to show up in order. So if I do select star comma and then some other stuff, that means the other stuff will be all the way on the right-hand side. It'll be all the way at the end of that list of columns. So I'm going to scroll all the way to the right in my hex board here, and I'll see episode number is going from 1 to 10. And if I scroll down, I will see going a little higher, and then at some point it's switching back over to start again from 1 in my episode number column, all right? Now I'm going to scroll back over to the right, or I could just make my view a little wider here. And I'll see that this is where my season number is different. Now it's put my seasons in sort of a random order, which is not super helpful. But within season 3, I can look at the dates and say, all right, my season 3 is still sorted by date. These are in order 1 to 20 something. And then same thing for season 6, which it's for some reason put next. All right, once it's doing the partitions, it's not really worrying about the order. It's just sort of going to return them potentially in some sort of random order. This is another case where I might want to add my order by. I want to order by season, right? And then also, now that I have my episode number, I can make sure that we're ordering by episode number as well. So the same way I can select multiple columns, I can order by multiple columns. So I can just order by season, comma, and then I'm going to refer to episode number right here. Cool. So once I've added my order by, it's going to update. And now I've got, okay, these episode titles look familiar, right? This is season 1 here at the beginning. I can come over to the side and I can see that season 1 is only 5 episodes long. It was sort of a pilot season, the whole thing. And then when I get to season 2, it's going to start again at 1. All right. So sort of 3 new things that we did in this query from our previous ones. We've sort of created new data, generated new data by doing select everything, comma, and then some sort of function, some sort of additional math, or in this case, just sort of a basic generation. We've put together this function, all right? This is a pretty common one that you're going to be sort of numbering things. In this case by season, but you could imagine other cases where you might want to partition by maybe what year different students are in, or different, you want to partition by category. There's other cases where you're going to want to be generating some amount of information within some sort of category. So that's what we've done here. And then the third thing we did is we did order by 2 different pieces of information, right? So this is the same thing as if you want to sort by last name, then first name, right? Same type of logic that we're doing here.
It's working only because of seasons already ordered by the air date, right?
Yes,
Okay.
great question. So yeah, so here, yeah, because they were already sorted by air date in our source data, we didn't have to do that sorting step. But yeah, if you had this data set and you noticed they weren't already in order, you would want to sort by or order by your air date before we did this step. Yeah, good question. There's maybe one more nuance to that question, which is that these dates are not in a super standard format. You can tell that because in hex, it's going to give you a little hint as to what the data type of each column is with this little icon next to each header. So this little symbol is going to mean it's interpreting it as a number, which for season is great. This A is going to say it's interpreting it as text, which makes sense for this title. But the A here, it would give you a calendar icon if it was interpreting this column as a date. But because it's saying A here, it's interpreting this column as text, meaning if we were to sort by this title, by this column, it would sort it alphabetically with these numbers and then alphabetically by month after the number, right, which would be a disaster, not what we want at all. There's a bunch of other work we could do to sort of get SQL to understand this column as a date and then sort, right? So that would be like yet another step. Thankfully, we don't have to do that in this situation. Good. All right. Any other questions about what we're doing with this query, generating our episode number? Okay. Fantastic. Cool. Okay. And then the last thing is to make sure that your column is titled as episode number with that little alias. Okay, great. So this is sort of our ratings data set, getting like that side of our join ready to be combined with our other data set, right? We have season, we have episode. We need to do a little preparation on our transcript data as well. Not because it doesn't have season and episode, it does, but because it's got more lines than that. It's not sort of summarized by episode in its current form. All right, so our next task, task number 7 here, is to summarize our transcript data by episode. All right, so this data set has the columns for season number, it has the columns for episode number, and we're going to add one more piece of information, which is how many lines does Elaine have in that episode, the character Elaine, how many lines does she have in that episode? And we're going to do that using group by. All right, so we're going to add some more SQL here. And our result from this should be 1 line for each episode with some information from our transcript, in this case, the lines, number of lines from this particular character. Number of lines is something we can get from our count function, right? Our count star. We did a similar query to this earlier. All right. Where we were counting lines by character in general. But what we're going to do here is season number, episode number, and the number of lines for Elaine. I would start with just our total number of lines, just our count star of lines, and you're going to need a group by 2 of our columns. So this is quite similar to a query we wrote before. So I'm going to give everyone maybe 4 or 5 minutes to figure this out, get a version of this query working. All right, I'm going to circulate around, so give me a little wave if you're stuck. And then we'll come back and talk about how to get those lines exactly for Elaine.
Did we combine 5 and 6?
Yes, we did. Yeah. Yep. So we're just jumping to task number 7. All right. So give her in a couple minutes. Right, I'm seeing quite a few people with partial queries for our little summary of our transcript data. Does anyone feel like they have a working draft of this query? Seems like a lot of people are kind of partway there. Okay. Let's talk through this one a little bit. So I'm gonna open up my data browser again on this side. So I've got my transcripts data column here for reference. Okay. So a couple things that I want to do here. First thing I want to do is my select. And then I'm going to grab my columns, the relevant columns that I need. In this case, it's season, episode number, episode NO in this data set. And before I count the number of lines for Elaine specifically, I'm just going to count all the lines. I'm just going to do count star, just going to count all the lines from my transcripts data. All right, now I am missing something here. So when I run this, I'm going to get an error message. We've seen this error a few times already. Season must appear in the group by clause. The reason I am doing this and not just typing in the group by clause is I don't want you to be scared of these error messages. You're going to see them a lot if you're trying to write a little bit of SQL. The best thing to do is don't freak out. Do not freak out if you see the error message, but try to read the first line or two of it. A lot of the error messages in SQL are pretty straightforward. They'll tell you at least some sort of clue about what you're missing. This is another example where we're just missing our group by clause. What are we going to group by? A good rule of thumb just to remember is that whatever we're counting, we're going to need to group by pretty much everything that's come before it. So we're not aggregating our season, we're not aggregating our episode number, we're aggregating sort of the number of lines that we're counting. So anything that we're not aggregating, we need to group by. So I'm going to group by those two pieces of information and see if that gets my error message to go away. It does, which is fantastic. I've also got my column still being called count star here. So I'm going to add my little alias as I might call this something like total lines. Okay. Great. And so now I'm getting a lot closer to a data set that I could join, right? I have my season number, my episode number, and then some other sort of summary information, in this case, total number of lines. Now we're going to add one more component to this query, which is the number of lines specifically for the character Elaine. Okay, so we're going to add one more sort of new function to talk about today, which is called a case statement. All right. So case is going to be used to select only rows where a certain condition applies. So we talked about our where clause before. Our where clause is applying a filter to the entire thing that we're selecting, right? If a row doesn't meet our where clause, it's just going to be fully left off of our results. Case is a little different. Case is going to say for this specific calculation, this specific aggregation, only count things that apply for a certain condition, but don't filter them out overall. Meaning the query that I just did here where we got our total lines, the number of lines that Elaine has in each episode is going to be less than the total lines, but we'll still have this information, right? We're not totally filtering it out of our results. We're just filtering it out of one of our columns. Okay. So to do that, we're going to do another count, but instead of just counting everything, we're going to count a certain situation. We're going to count a certain condition or case. And we're going to tell it a few pieces of information. We're going to tell it what that criteria is. So case when something is going on. So we're going to put something here. Then what should it count? What thing is it counting? So we're going to put something there in a second. And then we got to type the word end to tell it that the logic has concluded. Once it has found the when, counted the then, we're done. This is our convention for how we do a case statement, all right? Be case when something, then something else, end. All right? Now, the thing I want this to result in is the number of lines from Elaine. So I'm gonna call this, I'm gonna give this a little alias here. I'm gonna call this something like number of lines Elaine. Okay. Now, what my criteria here is that Elaine is the character, right? That's my criteria. Character equals Elaine. So my when is gonna look very similar to the where clause that we did in a previous thing. I'm gonna do where character equals some value. Now, when I'm matching on text in SQL, the text is gonna need to match exactly. For the sake of simplicity, there's ways to do it a little fuzzier, but for the simplest cases, it needs to match exactly. So I need to double check exactly how Elaine is spelled and capitalized in my data set. Okay, so to do that, I'm going to scroll back up to some query that we did before that mentioned characters. Okay, great. Here we counted number of lines by character, and Elaine is spelled like this, all capital letters. All right, so I'm actually just going to come up here and copy paste exactly how it's spelled here so I don't make any typos. But it's got to be spelled in all capital letters for this query to work. Okay. So I'm going to come down here and I'm going to put it in single quotes. All right, in order for SQL to understand that something is a string of text versus like another column name, I've got to put it in those single quotes. Hex is going to help you out here and color it in pink when you do that, or like a reddish, I guess it's more of a red. So you'll know that that's working. All right, but you're gonna need to put the character name in. All right, so what are we going to count in this case? In this case, we can count either the lines of dialogue themselves or just the number of rows. So we could count dialogue here, or we could count star after the then. In this case, every line of dialogue is filled in, so those two things are equivalent. All right, so when the character is Elaine, count her dialogue. So the sort of implicit assumption there is if the character is not Elaine, do not count their dialogue. And then that's the end of the logic. So then we get to our end and give that column the title, number of lines, Elaine. All right. So now we've got one more piece of information added to our data set. So same three columns here are the same as before, our total lines. This is still 230. This didn't change. Oops, looks like my episodes got out of order though. So I'm going to add an order by here. Order by season, episode number. Just to keep things a little bit tidier. Okay, great. So I've got my total number of lines from Elaine specifically. So it looks like Elaine is speaking about 10% of the time in this first episode. Okay. Any questions about what we did with our count case statement here? Case statements are just a little tricky because you got to remember all these this kind of set of keywords. So you're going to need case when, some condition, then the thing you're counting, column name you're counting, end. All right, don't forget the end. I know it seems quite obvious to our human brains, but it is not as obvious to SQL. Okay. So you should come up with something like this. All right, any error messages or any questions? Yeah.
I did something to you about it doing something wrong.
It's doing something wrong. You're getting a wrong result or you're getting an error message.
Wrong.
Ah, okay, let's see. Syntax error at or near count. Has anybody else gotten that error message on this class yet? Couple of hands. Okay, great. Syntax error commonly means you've misspelled something or you're missing a comma. Okay, you got to have a comma in between all of your different values. So you'll notice in mine, I have a comma after season, after episode number, and after total lines. All right, so I would check that you're not missing any commas. Okay, and that should make it run. Okay, great. The other reason you can get syntax errors is if you just do a total typo. If you type like form instead of from or something, that'll give you a syntax error. You'll also get a visual cue because it won't like highlight in the same way. Okay. Any other error messages come up? Okay, excellent. So we're going to add a little bit more information to this query. Yeah, question? Binder error. Okay, what does it say after the binder part? Column Elaine not found. Okay, so Elaine is not a column, right? Elaine is a value, which means probably you either don't have Elaine in quotes here or you have Elaine in double quotes. If you're missing quotes or if it's double quotes, it's going to try to interpret that value as a column name. The single quotes is what's going to tell it that it's a text string. Excellent. Okay. Good. All right. We've been troubleshooting a couple different kinds of errors. Hopefully you're starting to get a sense of how those work. All right. So we're going to take this query now, and in our next task, we're just going to add a couple more columns to this before we join it on. All right, we're going to add columns. We have the number of lines for Elaine. We're going to add columns for the number of lines from the other major characters as well. Okay, there are 3 other major characters in the plot of Seinfeld. So we're going to add 3 more columns for each of them and their number of lines. Okay. So what we're going to do is you should copy the query that you just wrote. I'm just going to copy this whole thing and I'm going to paste it down into another cell down here. And you're going to add a couple more columns. We're going to have, in addition to number lines Elaine, you should add a number lines Jerry, a number lines George, and a number lines Kramer. Okay, remember that those character names are going to need to be spelled exactly the same way, and that you're going to need commas between every column that you add. I'll give you a couple minutes to try that. I'll wave if you're stuck. All right, anybody figure out how to get the number of lines of Jerry dialogue in here? You're in the front. All right, you want to tell us what you added?
Yeah, it's just the same line as the previous one, but you changed the quotes to Jerry in all caps, and then number of lines is underscore Jerry.
Beautiful. All right, excellent. So writing SQL is a great time to copy paste. All right, it's a great time to avoid typos. If you know something does not have a typo, copy pasting it is a fabulous idea, and then making a few edits. So all we're doing is copy pasting our line about Elaine. Only change I made to that line is I added a comma here to avoid that syntax error that we mentioned. All right, so I've added a comma. Then I'm going to come down to my new line and I'm going to change Elaine to Jerry. I need to change it in one more place. I need to change it in this column name. Make this more descriptive, something like number lines Jerry. All right, I can run that, and I'm expecting Jerry as the main character to have more lines than Elaine, so this kind of passes my gut check. If I had misspelled Jerry, for example, let's say I only got one R in there, then these are going to come up as zeros. All right, so that doesn't pass the gut check, right? I know this character is sort of the main thing, so I'd go double check my spelling. All right, so this is another good habit. Every time you're adding something to your query or writing a new query, you want to kind of look at it and say, okay, does this actually make sense in the context? Do these numbers or values make sense? They should always make sense. All right, and we could add as many of those as we want for other characters as well. So I can just paste in, same thing I could do for other characters, Kramer, George, etc. And I'm just adding more columns of information this way each time I add one of those commas. Okay. Cool. All right, now we are almost ready to join our data together. Okay, this is very exciting. Now, we have a couple more little pieces of cleanup to do. This data that we just did all this work on summarizing with our total lines, a lane, etc. We want to give it a helpful name. Right now, mine is called data frame 11. Yours is probably called data frame something. We want to call this something meaningful so we can refer to it on our next query. So I'm going to call this something like transcript data summarized, something like that, something to indicate, or like aggregated, summarized, something like that. You want to give it a descriptive name. The trick with these, with like naming things, is to make them like err on the side of making them longer and descriptive. Don't like abbreviate them as like TDS for transcript data summarized. You're not going to remember what that is later. All right, so give it a good descriptive name and make sure it shows up in your data browser with that name. Okay. All right, next thing we're going to do is do the same thing for our ratings data table where we added our episode number. Okay, so the one where we did our whole row number over partition thing, I'm going to scroll back up to where that one was. For me, that's data frame 9. And I'm going to give this one a meaningful name as well. All right, this is the one we wrote up in task number 5. So whichever query you wrote for that, we're just going to double click this little green tag right underneath that cell and just change that to a meaningful name. I'm going to call this something like ratings data with episode number, something like that. Okay, just give it something that makes sense to you. All right. So we have our ratings data set, what we've sort of prepared to join. We have our transcripts data set that we've prepared to join. We're going to do the actual join now. The very last thing we need to check before we do that is that our column names that we want to join on, the columns that we want to match between, are labeled the same way. Okay, so we're going to join these together based on 2 columns. We're going to join them based on season and episode. Okay, so this column is called season, and then episode number, episode underscore number. All right, and this one. And then if we go down and look at our other table that we just made, this guy, season is spelled the same, but episode no is not, right? That's different from episode underscore number. So I'm going to do one more little cleanup task, which is I'm going to add an alias on this one. I could do it on either one, but I'm going to add an alias on one of them so that they're the same. Okay. So in this case, I'm going to add an alias to say as episode underscore number and just rerun that with that little update so that it's labeled. Those 2 columns are labeled the same way in both my tables that I'm going to join. That's just going to make it a little easier for me, this next step. Okay. Excellent. Anytime you make a little change like that, even if it's just a little alias, always run your query again, make sure it runs. Okay, so now that we've got all that done, we're going to do our last sort of task query of class, which is to join our 2 data sets together. Okay, now this query is going to look sort of oddly simple after some of the queries we just wrote. We just want all the columns from these 2 tables to show up in the same place. All the columns means we're going to select star. Okay. I can select either table to start with. Typically the one when you're joining 2 tables, you want to start with the one that you feel has more reliable data, whatever that means. In this case, I'm going to go with that ratings data. Now remember, I'm going to select this one that we just relabeled because I need that one with the episode column. I can't just select this one because it's missing that episode column. I won't be able to join. Okay, so whatever you named your table from the one where we did the row number part of our query, you're going to do that. And then I'm going to add my join. And this is where I'm going to give it the table name of my transcript data, one that we did with the number of lines from each character. So mine is called transcript data summarized up here, whatever you called yours. You're going to just join that on. So I'm going to do join and make sure I get my transcript data summarized. Great place to use little autocomplete to make sure I'm not doing typos. Now, the last piece I have to tell it for a join is which columns to look at. We just did all that work to get those 2 columns organized. All right, so we're going to do join using, this is our next keyword, Then we're gonna give it some parentheses and we can give it one or more, however many columns it needs to join these two data sets together. In this case, we need those two, season and episode number. Okay. Join this one table, so select everything from this one table and join on this other table, everything for both tables, using those two pieces of information. And that is our whole query. All right, so once we've done that step, you should get some results like this, which will have all the columns from our ratings data set, plus our episode number, plus all of the columns from our transcript data summarized, meaning total number of lines from Elaine and Jerry, etc. Okay, so we did a bunch of sort of more complicated queries to get us to the point where we could write this query easily. A lot of SQL is like that. You're sort of preparing your data for whatever you expect that you or someone else might want to do with it. In this case, join. This is now a very cool data set. This is a much cooler data set than what we started with, because now I could take these two pieces of information and do some interesting data analysis, right? I could pick my favorite Seinfeld character. Let's say mine is Elaine. It is, in case anyone was wondering. I can take the number of lines from Elaine and I can compare that to the average rating per episode. I could look at the percent of lines from George and see if that might correlate to, let's say, a lower episode rating, right? I've got this cool combined data set. I could do even some kind of basic statistical content analysis on this. That's very cool. I could not have done that from those two separate data sets when I started, right? I needed to do all this work to join them so that I could do something cool like that. I could statistically prove that my favorite character is better for the ratings, right? Pretty cool. Okay, so that was a lot of SQL, especially if you have never looked at SQL before today, which I think maybe some of you have not. That was a lot of SQL. Okay, we wrote a bunch of queries. You have this copy of your notebook. So what we're gonna do next week is we'll review all this and we'll also write some more queries. We'll talk about data modeling, which is kind of the exercise we went through today of preparing data to make it easy to query for specific cases like joining. So we'll do more of that next time. But you have access to this Hex account. You can like go back and play with this. If you didn't get to any of the queries in the session today, you can log back into this later and muck around with it if you want. And this recording will be on the Digital Lounge website as well. So that's all that stuff. Okay. We'll be back here next week for the next part of SQL. Like I said, we'll be doing Python the 2 weeks after that, and then we'll kind of tie it all together in that final week. I listed a couple other tutorials on here. Hex itself has some great tutorials on its website that are just sort of learn SQL, Python. There's a cool kind of murder mystery tutorial for sort of SQL learning or review that I would highly recommend. And then there's a bunch of sites that sort of give you more standard tutorials if you want to kind of learn a little bit more on your own. That's all I got. So hope to see you all back next week for SQL part 2. I'll hang out for a few more minutes if you have questions or error messages or anything you want to chat about. Thanks, everybody.
Ratings mail.
Okay. Yeah, totally. Yeah, I mean, you're welcome to pop in partway through if you like. We'll have sort of a introduction session, so you might get to spend a few minutes kind of catching up. So yeah, you're welcome to pop in halfway through, and then the recordings do get posted afterwards, so you can always. Yeah. Awesome. Cool. Thank you.